Welcome to The Explainer. Today, we're tracking down an invisible thread that connects the gritty, analog world of earth sciences directly to the hyper-fast, volatile realm of algorithmic finance. Seriously, it's a wild journey about finding immense value hidden inside absolute chaos, and the incredible math required to actually pull it to the surface. Let's get into it. Okay, let's jump right in with a riddle for you. What in the world could a 1980s Soviet geology dissertation, literally typed on physical paper and studying ancient rocks, possibly have in common with a modern Python trading bot programmed to execute cryptocurrency trades? I really want you to hold that central mystery in your head as we go through this, because as we piece this puzzle together, the answer is honestly mind-blowing. So let's look at our very first artifact. This is a physical typewriter font doctoral thesis, straight out of Moscow State University. The year is exactly 1980, and the author is V.G. Chernov. Now, this thesis is entirely focused on the chaotic layers of the Earth's crust. It analyzes millions of years of geological history to figure out how intense, violent forces shaped our planet. Basically, it's a foundational text for reading the buried, chaotic memory of the Earth. And the specific focus of Chernov's work? A geological formation called psephites. Now, to translate the heavy jargon for a second, psephites are just incredibly coarse, fragmented, sedimentary rocks. Think of massive, messy conglomerates of rubble. But here's the thing. In geology, these aren't just random piles of rocks. They are absolutely critical indicators. Because they only form during intense, chaotic movements like mountain building. They basically record massive, unpredictable shifts in the Earth's crust. They're literally nature's anomaly detectors. But Chernov makes it crystal clear that reading these chaotic layers isn't just for academic fun. The text explicitly points out the massive practical significance here. You see, understanding these chaotic formations is basically a highly lucrative treasure map. It's the key to finding the world's most valuable hidden resources. We're talking gold, uranium, platinum, and diamonds. If you can understand the noise of the Earth, you can locate the signal. And that signal is immense value. To really drive this point home, the text highlights an absolutely staggering number, 100,000. The dissertation notes that throughout human history, roughly 100,000 tons of gold had been mined up to that point. And here's the kicker, nearly 2/3 of all that gold came specifically from these messy, conglomerate, persephitic rocks. All that insane wealth was locked inside chaotic, fragmented data left behind by tectonic violence. And this brings us to a huge, overarching theme. Whether you're out freezing in the Carpathian Mountains in the 1980s or sitting in a server room today, prospecting is a universal human pursuit. At its core, it's the art of extracting hidden value from massive amounts of chaotic, noisy data. It's the ultimate filtering process, right? You literally have to discard mountains of dirt just to find that one tiny golden signal. Which leads us to a pretty dramatic pivot. We're leaving the mountains of the Soviet Carpathians behind and diving straight into the digital ether. Think about it. What happens when the chaotic strata you're looking at isn't ancient sedimentary rock, but the highly volatile, microsecond by microsecond data of a modern algorithmic trading bot? Let's check out our second source, a highly optimized Python script specifically built to hunt for profit in the wild crypto markets. Now, a geologist might use physical tools, but our Python training bot uses what I like to call digital pickaxes. The source code deploys some intensely advanced mathematical filters to systematically chip away at financial market noise. We're talking wavelets to measure energy, Mahalanobis distance to track statistical anomalies, Fourier transforms to analyze frequencies, and LSTM neural networks for pattern prediction. These algorithms are aggressively mining the data stream, just waiting for a disruption. Let's zoom in on one of the heaviest hitters in the bot's toolbox, the Kolmogorov ensemble. The code uses this technique to fuse multiple complex mathematical models together. Its entire job is to score the complexity, entropy, and energy of market movements. If a massive, totally unpredictable shift is happening in Bitcoin, a real anomaly, the Kolmogorov ensemble flags it. It mathematically separates the meaningful tectonic shifts of finance from just the everyday random background noise.
And wow, this brilliantly illustrates our central connection. Over in earth sciences, you've got geological indicators, those psephites, marking violent historical shifts. Over in algorithmic finance, you've got algorithmic indicators, like the Kolmogorov ensemble, marking massive, volatile shifts in market data. Both disciplines are doing the exact same thing. They rely on specific, high-energy markers to make sense of huge, unpredictable environments so they can extract value. But guys, the connection isn't just a fun metaphor. It is completely literal. Buried deep inside the Python code of this modern trading bot is an incredible little detail. The code implements this complex matrix filtering algorithm, and right there in the comments, it directly credits a 2011 Russian patent by a guy named Vadim Chernov. Yep, the legacy of complex data analysis, from VG Chernov mapping chaotic rocks in 1980 to Vadim Chernov patenting digital matrix filters in 2011, ties our two sources together perfectly. How crazy is that?
Actually, it goes even deeper. Take a look at this. The bot's Python script explicitly defines a function called hybrid geofilter. Just let that sink in for a second. This highly advanced financial engineering algorithm is literally borrowing the exact language of the earth sciences. It's a geofilter, but applied to a digital matrix. It absolutely proves that the math used to sift through physical dirt and the math used to sift through digital numbers are, fundamentally, the exact same thing. So how does this hybrid geofilter actually run in the code? Well, it's a neat three-step process. First up, it detects massive anomalies in the raw data stream. Second, it calculates the signal-to-noise ratio, which is basically the algorithm asking, hey, is this actual gold or just a shiny reflection? And third, it rigorously filters the data matrix to pull out only the high-probability signals. Honestly, it is the exact digital equivalent of panning for gold in a muddy river. Just like a physical miner has to throw away tons of worthless rock to find a single ounce of precious metal, this computational pipeline eats a massive volume of total raw data chaos. It systematically identifies the noise and just chucks it out. And what remains at the very end of that computational funnel? That tiny, highly lucrative, extracted, valuable signal. So, what is the big takeaway from our explainer today? Simply put, whether the wealth is buried miles deep in the Earth's crust inside ancient rock or hidden inside the rapid-fire chaotic price history of Bitcoin, raw data is inherently messy. The value is almost never just lying around on the surface. Value only exists for those who have the insight and the math to build the right filters to find it. I want to leave you with a provocative thought as we wrap this up. We've just seen how some incredibly brilliant minds filter the Earth and the financial markets. Take a look at your own complex world. What chaotic, sedimentary noise in your life, your business, or your own learning is currently hiding a golden signal? It's out there, just waiting for you to build the right filter to discover it. Keep prospecting.